I love this city. Everything about it. Food, culture, heritage, people, or how they complete each other. It's like the city is made for young people to learn and to be creative. In this mesmerizing city, I'm glad to be here.
For years, AMIKOM has tried to make a suitable place for their students to feel more enjoyment in their learning process. We believe that learning is not something that the students should do, but it should be something that they want to do. That's why we always support everything that relates to creative and fun learning activities. It is the essential idea of creativity, associating fun and learning all together.
One thing that I love about this university is that they allow us to experiment and try to make new things. It's okay to make mistakes and learn from them. So that's why they built so many facilities, labs, and also they have professional companies. We call it Professional Lab. We can experience what it is like to be in the real industry, what we need to be, the attitude, the skills, and everything that makes us valuable out there. It's like we are well prepared for something big.
When I first got here, I was completely full of worries. Not because of entering a new phase, but about the future. I wasn't sure of what I was supposed to do at that time. But it turns out that everybody does the same. And AMIKOM made it easier for me. Everybody supports each other. The lecturers, staffs, employees, and all of my friends, they are so lovely. We have sport activities and great facilities. The cafeteria is clean and neat. And the food, they are delicious. We are like coming into a big family.
If you are a person that into creative things, I recommend you to come here to feel the atmosphere.
Enjoy the fun with the combination of nature, the city, and romance.
Join us and let this place reveal the best of you.
Come on, join Universitas AMIKOM Yogyakarta.
love this city. Everything about it. Food, culture, heritage, people, or how they complete each other. It's like the city is made for young people to learn and to be creative. In this mesmerizing city, I'm glad to be here.
For years, AMIKOM has tried to make a suitable place for their students to feel more enjoyment in their learning process. We believe that learning is not something that the students should do, but it should be something that they want to do. That's why we always support everything that relates to creative and fun learning activities. It is the essential idea of creativity, associating fun and learning all together.
One thing that I love about this university is that they allow us to experiment and try to make new things. It's okay to make mistakes and learn from them. So that's why they built so many facilities, labs, and also they have professional companies. We called it Professional Lab. We can experience what it is like to be in the real industry, what we need to be, the attitude, the skills, and everything that makes us valuable out there. It's like we are well prepared for something big.
When I first got here, I was completely full of worries. Not because of entering a new phase, but about the future. I wasn't sure of what I was supposed to do at that time. But it turns out that everybody does the same. And AMIKOM made it easier for me. Everybody supports each other. The lecturers, staffs, employees, and all of my friends, they are so lovely. We have sport activities and great facilities. The cafeteria is clean and neat. And the food, they are delicious. We are like coming into a big family.
If you are a person that into creative things, I recommend you to come here to feel the atmosphere.
Enjoy the fun with the combination of nature, the city, and romance.
Join us and let this place reveal the best of you.
Come on, join Universitas AMIKOM Yogyakarta.
Hello, good afternoon.
Good afternoon, ma'am. Good afternoon. So, shall we start with the event?
Yeah, okay. Marona, we can start now.
Okay, we will start now.
Eh,
Oke, halo Prof.
halo.
Nah, kita mulai ya Prof ya.
Oke, please.
Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Okay, everyone, welcome to Masterclass Expert Talk Digital Image Processing. So this event is collaboration between AMIKOM, Universitas AMIKOM Yogyakarta and Chandigarh Universicity. So today is very special because this is one of the student mobility, and also we have very knowledgeable speaker today. So from AMIKOM we have Professor Dr. MC Yanta. He is a rector from our Universitas AMIKOM Yogyakarta, and also we have Dr. Kusrini. He is Director of Postgraduate Universitas AMIKOM Yogyakarta, and also we have Dr. Arif Setianto. He is Vice Rector Universitas AMIKOM. And also from Chandigarh University we have Professor Dr. Bisa Barti. He is professor and additional director CSE at Chandigarh University, and also the beautiful one. This is Netika Kapoor, assistant professor in Chandigarh University, and also all the participants in this Zoom meeting. I hope
all of you in the best condition, always healthy and also happy. So before we start, let me introduce myself. My name is Rona Gwines Prasewi. All of you can call me Rona, and I will be your host today. And so for all the participants, I please rename your profile with Amikom. For Amikom student, you can rename it with Amikom strip name strip program study. And for the Chandigarh University student, you can rename your name with CU strip name strip study program. Okay, so from Chandigarh University has joined with us, and but before, please all the participants, can you open the cam because we will take a picture together before we start this event. Okay, so can you please change your virtual background with what we share in the Zoom chat, and then we take a picture for this documentation for this event. And also this event we live stream in YouTube AMIKOM Yogyakarta channel. So if you want to rewatch again, you can go to our YouTube channel, AMIKOM Yogyakarta. Okay. Okay, so the participant, please open the cam.
So I'm requesting my students from Chandigarh University to please switch on their cameras and rename yourself as CU underscore your name.
Okay. Yeah. Okay. We still wait until the page one is full.
I can see many of you have still not switched on their cameras. Please do it quickly.
After open the cam, we can see the difference. Who is Indonesian student and who is India student. Okay. So are you ready to take a picture? Okay, the first picture, freestyle. You can do whatever you want. Maybe thumbs up or peace sign or everything, okay? I count 1, 2, 3. Okay, once again, this is signature pose of AMIKOM, holding the world like this. Creative Economy Park, okay? Okay, 1, 2, 3. Okay, Miss Nitika, maybe from Chandigarh University, there are signature pose?
No such signature pose of Chandigarh University, but still I'll do this.
Oh, okay, thumbs up. Okay, once again, 1, 2, 3. Okay, thank you. And then maybe you can give the reaction to today's activity because it's very, very interesting. And I think we will start today. And in here, there are Mrs. Nitika Kapoor. Hello.
So let's start. Hi, ma'am. So let's start our event.
Okay, Miss Nitika Kapoor, time is yours.
Okay, thank you, ma'am. Thank you so much. Good afternoon to one and all present here in this online session. It gives me immense pleasure to welcome our guest speakers in this session. On behalf of Department of Computer Science and Engineering, Chandigarh University, I would like to take this opportunity to introduce our guests to the participants of this event. We have amongst us Professor Mohammad Suyanto, Professor Kusrini, and Professor Arif Setyanto. I'll first start with the introduction of Professor M. Suyanto. He is a rector of University of AMIKOM, Indonesia. He is a movie producer and a successful film writer. So that is the best thing that has an attraction today. So he is also a professor of strategic management, marketing, and e-business. Sir has written many books, and the most famous one is Muhammad Business Strategy and Ethics. He is an Oscar winner for The Secret of Screenplay. So I welcome you, sir, on this event. Secondly, we have amongst us Dr. Kusrini. Dr. Kusrini has a rich experience in the field of research and academics. She is working as Director of Graduate Programs at University of AMIKOM. She has published numerous of research papers in the field of image processing and machine learning. She has also received grants for various research projects from the Government of Indonesia. Dr. Kusrini has many patents and books on her name. Last but not the least, I would like to introduce Professor Arif Sianto from University of AMIKOM, Indonesia. He has fetched numerous of research grants on his name and has published many abundant research papers in the field of image processing. So on behalf of Computer Science Department, I extend my heartiest welcome to our esteemed guest. So with these words, I request Professor Sianto to start the session. So Professor Sianto, the stage is all yours. So you can start the session.
Okay, thank you, Ms.
Thank you so much, sir.
Yeah, thank you very much, Ms. Nitika Kapoor. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Good afternoon.
I would like to talk about Universitas AMIKOM Yogyakarta. I have divided my presentation into parts. First, my speech. Second, my video profile, AMIKOM video profile. Because limited time, I present quickly about Universitas AMIKOM Yogyakarta. I would like to show a profile of Universitas AMIKOM Yogyakarta.
Friends, I have known AMIKOM now for over 3 years, and the relationship started with knowing Professor Suyanto, and I've known all the team here, I've known the students, I've known filmmakers here. I believe this is a great platform, a great opportunity for students like you to come together, learn from each other, learn from the professors, learn from the teachers. I think most importantly as students, this university provides you an opportunity to come, learn here, and at the same time, an opportunity for a lot of you to actually start making films, animation films, and also be able to express yourself better. So use this opportunity, join AMIKOM, make sure that you have a huge career in front of you. Good luck.
Hello, I'm Steven Ista, President of California Pictures, based at Paramount Pictures Studios, Hollywood, California. And I I wanted to congratulate you on behalf of the Expert Advisory Board for the Rector of AMIKOM University, Professor Suyanto, a leading visionary in worldwide education. You will be educated and mentored by experts like myself and members of Disney, CJ Entertainment in Korea, Tencent in China, and other leading experts so that you may compete and win in today's global economy. Again, congratulations for choosing AMIKOM University.
Hi guys, nama saya Johan. I go to Seoul Institute of the Art. My major is interior design. Time is very special experience in my life because I am learning so many 3D max making and so many technology and so many kind of people. So I am happy. I am never go back home to Korea. Yeah.
Hi, my name is Jong-hoon. I'm from Seoul Institute of the Arts. My major is creative advertising. So I come to Indonesia internship program. Indonesia and Yogyakarta and MSV studio is good experience for me.
So Amikon is really a nice place. Everybody's really friendly. So we went to visit Borobudur, and it was really a nice place too. Everybody, the culture is really nice. The food is really good, and we enjoy it very much. Yes.
Okay, so well, the first day in AMIKOM was great. Everybody was so welcoming, and it was really a pleasure to come here and, you know, be greeted by all these people. And I think the place is great.
Okay, thank you for your attention. I think that's all. Peace be upon you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Cek. Cek. Prof, mohon maaf untuk share screen-nya bisa di off, Prof. Oh, sudah. Ya, terima kasih, Prof. Udah langsung live ya.
Okay, is that my turn?
So shall we start with expert talk now, ma'am?
Yeah, okay. Okay, good afternoon all.
I would like to welcome Dr. Kusrini to start with expert session. That is the session on research prospects and image processing. So ma'am, you can start with the session now. Thank you so much.
Okay, thank you, Ms. Nitika. Good afternoon all. Okay, how are you? I hope all of you are in a good condition. Yeah, I heard about coronavirus that's spreading in India in this last week. I'm really sorry to hear about it, and hopefully everything will be going well, including in India and in Indonesia. Okay, it's a honor for me to meet all of you here, Ms. Nitika, Prof. Yanto, Pak Arif, Mbak Rona, Chandigarh students, and also my students of AMIKOM, from AMIKOM. I really want to get chance to meet all of you offline, just like last year, I visited Chandigarh University. meet Miss Nitika and the students in Chandigarh. And sadly, it was become my last trip before pandemic. So yeah, because of the situation still dangerous because of the coronavirus present, we just meet in the virtual. But I hope it's enough for us to share about what can we do with digital image processing. Okay, I will give my talk around 30 minutes about introductions of digital image processing. Then I will give cases that have to be solved in group. Okay, in group. Its group will consist of some Chandigarh students and AMIKOM students. I will let you in breakout room to discuss, and please use that moment to know each other and trying to solve problem together. After discussion, I will ask you to show the result of the discussion, and then Pak Arif will continue with how digital image processing work in Python. And after this meeting, we will prepare certificate for all of you, but there is a requirement. You have to fill the post test and evaluation. So remember, there is a post test. So you have to pay attention to my presentation and of course Pak Arif's presentation too. Yeah. Okay, I will start with sharing my screen. Wait.
Can I say something, ma'am?
Okay.
I just want my students to know this, that ma'am would be creating certain groups, the groups of students from the University of AMIKOM and our students from Chandigarh University. And you would be asked in the end of the session, you would be asked about certain questions and you need to attempt those, and based upon those, you would be given a certificate and your grade would be specified in the certificate as well. So be attentive, listen to what ma'am is saying, and do please be interactive during your group sessions. When you will be interacting with the students of AMIKOM, please do be interactive, okay? And do listen to ma'am carefully. So that's all what I have to say. So ma'am, you can start.
Thank you. Okay, yeah. Yeah, let's start with the image. Do you know what is this? Okay, this image is taken from my Facebook. Okay, some images when I visited Chandigarh University. Am I the only one that upload my activities in Facebook? Have you did the same with me? Okay, do you have a social media account?
Do you have social media account?
Yes, I have.
Yeah, okay. I think almost all of us
Yes, I have.
have social media account. Yeah, maybe not only us, but almost all of the people in the world, and sharing many things. Even if we are in suffering condition, sometimes someone prefer to take the picture and share it first before eating their food. Okay, and because of that, the image video are everywhere. Not only about food, it's only about traffic, it's only about medical image, and also many more. Yeah, and when did the picture and videos come from? Okay, we can use our digital camera, and then we can also use our smartphone or a camera of our laptop, or using a web camera, or using a CCTV, or maybe we can use a body scanner or health imaging, and many more. Okay, and this is the one of the example images that are taken from satellite. This image shows that what's called a point fire point in Indonesia in a time. So this shows how the condition in Indonesia that taken from a satellite. Okay, and this one is the other things we can take the picture using multispectral camera. And then what can we do with those images? Okay, we can use only something inside manually, okay, analyze something inside manually, looking that image, and then we can decide something, we can conclude something, or just keep the image in our memory. Yeah, but of course, we can also use all of this image to perform analysis using digital image processing. Okay. What is the digital image processing? Yeah, we can divide digital image processing into two parts, for computer vision application and for human vision application. Okay, the computer vision application, the output is used by a computer, while a human vision application, the output is consumed by human, like image restoration, enhancement, compression, and etc. Okay, this is the goal of computer vision, how to bridge the gap between pixels and the meaning. Okay, what we see is like the left side. Okay, we see something there. Yeah, the accident train, and then computer will see only numbers. Okay, numbers in matrix. This is the concept of digital image. When we have an image, a digital image is a representation of a real image as a set of numbers that can be stored and handled by a digital computer. In order to translate the image into numbers, it's divided into small areas that call pixels. Okay, we use a two-dimensional signal like function x, y, where x and y are the spatial coordinates. This is the pixel grid. Yeah, we have x-axis and then y-axis. And if we want to see the value of the axis, for example, 1 point and function of 1.1, so we will see the column row, the column 2, yeah, column 2, and then the row 2. I will show you here. Okay, 1, 1, because it starts from 0, 0, 1, 2, and etc. So if I want to get 1, 1, so it will be here. Okay, and this color will be represent this number. Okay, and the other one, this one is 0, 1, 2, 3, 4, 5, and 0, 1, 2. So it's 5, 2, and this color represent this number in red, green, and blue. So this is the red number, green number, and then the blue number. Okay, I think it's easy for understanding this. Okay, and the image types can be binary or monochrome, while the color is only black and white. White represent in 1, and black is 0. And then we also have gray image that the intention, the intensity is from 0 until 2 power n minus 1. I think I have a difficult mistake here. Wait. Okay, this one should be like this. Oh, yeah. Yes, it's true, like this. And if I have 2 bits with n is 2, so it's mean the number in this grid will be 0 until 2 and minus 1. 2, this will be 4, and then minus 1, so it will be 3. So the number is between 0 until 3. And what about 8 bit? If we have n is 8, so it will be 2, 8 minus 1. So it will be 256 minus 1. Okay, from 0 until 255. So the value in this pixel will be in that range. Okay, this is the gray color, the gray image. And then we have also color image. The color image contain of three: red, green, and blue. It's depend on how many bits. And this one is red, and then green, blue. Okay. Okay, and then image processing. There are two main type of image processing. It can be image filtering or image warping. Image filtering means that we change the range of the pixel of an image. Okay, this is the example. So I have original image in the left side, and then I will manipulate the value of the pixel so that the image will be like this. Okay, the color maybe will be changed with another color and etc. And the second one, image processing, can be image warping. Image warping means that the color is still the same, the pixel value is the same, but we will change the position. Okay, we will change the position so that it will be like this. Okay. What can we do with that digital images? Okay, most computer science research tries to build a human-like robot that is able to function exactly as human using a sensor. The robot feels the temperature in the surrounding environment and then using facial expression. It is possible to know whether a person is sad or happy and etc. At the current time, a very challenging application is object recognition. Recognition can be based on different types of data, such as audio, image, and then text. And image recognition is very efficient way due to the plenitude of information that can be helpful in the task. Okay, but why we have to study digital image processing or computer vision? We know that vision is useful, right? And then vision is interesting. We have many image and video, okay, but unfortunately vision is difficult and challenging. How can it be? Okay, this is the example. This is the situation when there's a few point variations. Okay, and this one, illumination, scaling, deformation, and then occlusion. Yeah, maybe it's difficult for a computer to make difference between the background and the object in front of that. Okay, because the background is similar with the object itself. Okay, this is the motion, and we know that every object have a variation shape, so it will be difficult for us to not for us, but for computer to identify is it a chair or else, while we have many variation of the chair shape. Okay, and how computer vision in the real world. This is the shape and motion capture, and then this is face detection application. Okay, we can identify who are in the image, and this is the smile detection. We can see while someone is smile or maybe sad or else, and then it's also face recognition. Okay, biometrics, how the Afghan girl was identified by her iris patterns. Okay, and then this is a biometric too. Yeah, fingerprint scanners, and we also can use technology to convert scanned docs into text. We also can use mobile visual search. Okay, we also can use to automotive safely and also to count the number of things that we buy in a supermarket. Okay, This is a vision-based interaction, and this is medical imaging. Okay, and we also can use computer vision to surveillance and traffic monitoring. And what is AMIKOM doing with computer vision? Okay, this is one of our research, me and Pak Arif doing this research. This is my mango in my yard. Yeah, mango plants are popular commodity and export potential. The presence of pests that attack the fruit, stem, roots, or leaf of the mango will greatly affect to the production and quality of the mangoes. And we have many types of mango pests, and the many types will make farmer difficult to identify what types of the pests that attack their mango. So we need tools, yeah, to help farmers to detect mango pests and provide solution to their handling. Okay, this is the scheme. So we made mobile apps that are connected to the machine learning server. And this is the prototype. The image can be taken from a gallery or a camera from mobile application, and then system will identify the type of the mango pest, and then system will give detailed information about the pest and give advice how to handle the pest itself. Okay, this is the back end. We provide some management for the expert, and it served in English and in Bahasa. And then this is the data collection. Before we make a model, we capture leaf image naturally from the field without any pre-processing, and then we collect it and make a training. Yeah, we divide into 15 class of pests, and we use CNN. Pak Arif will show you how to make it. And then this is the augmentation process to make our algorithm give the higher accuracy. And this is the scheme. So data collection, and then we will give label to the image by expert. And then in the computer server, we make image database, and then we have a VGG16 extraction, and we use FCL, and we have model. When the farmer have image that taken from their smartphone, then the system will classify and take the knowledge of handling that pest and giving feedback to the farmer using their application. This is our application has been provided in Google Play and has been used by farmer in Indonesia. And we have published in computer and electronics agriculture, and also in a conference, international conference. This is the other example of the research in computer vision area. Okay, how to use image processing computer vision to detect COVID-19 using chest X-ray image. In the slide, we can see the image that have COVID-19 and the normal image. Then we will train that image, and after that we can use to classify the new image that given to the system. Okay, and the other one is security of facial biometric authentication for attendance system. It's done by my students and also helped by Ms. Nitika. Thank you, Ms. Nitika, because of our collaboration.
Thank you, ma'am. Thank you.
This paper has been published in Q1 journal, and this is the result. So the application can identify who is that present, and are they in the session or not. Okay. And this one also the collaboration between me and Chandigarh student, Omid. He asked me to give supervision of his paper, and it has been published in our conference in AMIKOM, international conference that held by AMIKOM. Okay, and we also invite you to submit your paper, your idea, because we will conduct ISO SCT 2021, and Ms. Nitika also will be a reviewer and also a session chair in that conference. So students from AMIKOM and Chandigarh, we invite all of you to share your research in this publication. Okay, to see another publication, you can see in my blog, yeah, in my web. And what is the basic concept of computer vision? Actually, computer vision building block is like this. Yeah, we take perception, image acquisition, and then we do image processing, feature extraction, and then pattern recognition, and then give action for the result. And image acquisition, I think it's easy. How we take the. Sorry. Okay, the take picture from using our tool, and then after that we can do grayscaling, change the color image become grayscale image. Okay, this will be one of the question in the post test, so you have to give attention to this part. Yeah, yeah. For example, we have image in RGB, and this is the number intensity in each pixel. Yeah, so when I want to transform it into grayscale, so what I do is, for example, this one, it's come from 0 to 99 from the red part. The red part in this point is 32, so it will be like this, and then I will add with 0.587 times 0 and plus 114 times 35. So, and after we get the number, we will round it and get this number. So the new image will be the gray image, not in RGB again. There's a standard, we can use NTSC when R, G, and B have different proportion, but we also can use mean. So if mean, we only make average 32 plus 0 plus 35 divide by 3. Okay, it also can be done. So the number will be 22. Okay, and then after that, we if we want to process the image, we need to take image visual features. There are some of the features that can be taken. Some of them as color and texture. Color can be a color histogram, and then mean, color moment order one, and then deviation standard, skewness, yeah, and etc. And I will show you one of them, color histogram. If I have an image like this, I have an image, this one, for example, this is the metric of image. And then if I want to make a histogram, so I have to make a bar. This is the minimum number of this image is 0, and the maximum is 3. So I will have 0, 1, 2, and 3. And then I have to count the number of pixels that have value like this. 0, I have 1, 2, 3. So it's right here. And then 1, I have 1, 2, 3, 4, 5, like this. And I can make a graphic, yeah. This is the pin or bar, 1, 2, 3, 2, 3, and this is the amount of that pixel that have value like in the bar. Okay, I think it's still easy for you. Okay, next, this is the example of image database retrieval. I have an image and then I will looking for the similar image in a folder, and then I will make a histogram for all of the image, and then I will compare which one is the closer. Okay. This is the example. If I have two image 1, image 2, and then I have image X, and I want to know which one of the image 1 and image 2 is more similar to image X. So I have to make a histogram. So this image, those image is between 0 until 7, right? The number, and then I will have a bar or pin in 0, 1, 2, 3, 4, 5, 6, 7, and then I have image 1, image 1, and then image 2 and image X. Okay. Okay, for example, this one. For image 1, this one, I will count the number of 0. It's 0, 2, and then 1, we have 2, and then 2, 2 again, the 4 is 1, and then 5 is 0, the 6, 0, and then 7, we have 2, yeah, and then it's also done in image number 2, and then image X. In image X, we have 0, and then 3, 2, 2, and then 2. This come from this one, yeah, 2, and then 5 is 0, and the 6 is 0, and 7, 0. So I can compare the image 1 and image X by using distant formula. Can use Laplace or Euclidean. If I want to use Laplace, I just look the difference from image 1 and image X, yeah. 1 and X is 0 minus 0, and then plus 2 minus 3, and then plus 2 minus 2, and etc. And then I will sum 0 plus 1 plus 0, and etc. And I will get the number here. And I also will count the distance between image 1 and image, image 2 and image X. So I will have distance between image 2 and image X. And then I will get a number, and I will compare the image 2 and image 1. Which one is smaller? The smaller means it's closer. So I can conclude that image X will be similar with image 1 or image 2 that have a smaller result of the Laplace distance. If I want to use Euclidean, so this number has to be make like this, okay, and then it will be summarized and will be what is called root, yeah, root of the number. Okay. Okay. Next, I want you to discuss in group. Okay, to create a grayscale image. From this image, I have a RGB image, and then I want you to make a gray image using NTSC, yeah, using NTSC. And then the second one, I want you to looking for the similar image given matrix of 3 images below between image 2 and image 3, which one is more similar with image 1. So you have to count the distance between histogram between image 2 and image 1, and then image 1 and image 3. So if the smaller is image 1 and image 2, so we can conclude that image 1 is similar with image 2. Okay, I will put you in the breakout room and I will give you 15 minutes to know your group friends, your group members, and discussing these two cases, grayscaling and measure the distance between an image with the other, so you can recognize which images are similar. After 15 minutes, you will automatically bring to this room, to this main room, and I will ask you to share the discussion result, and after that, Pak Arif will explain about how to implement this concept in Python. Okay, give me time to put you in the big breakout room.
So I'm requesting students again to take benefit of this situation that you people are going to interact with the students of University of AMIKOM. So please be interactive during this session.
Okay, I will make sure that in a group there is a student from Chandigarh and student from AMIKOM. Okay, I will let you in the breakout room. Please enjoy your room, discuss with your friend, and then we will back to this room after 15 minutes, right? 15 minutes automatically you will be bring to this room again. Okay.
Gurini, where do you share the file for the breakout room? I think some of them do not know where the file is.
Halo Pak Arif, gimana Pak?
Itu Gurini nge-share file apa? Di breakout room, cuma kayaknya teman-teman di breakout itu nggak pada tahu tuh tugasnya ngapain.
Menjelang berbuka Pak, biasa.
Oke. Bu ini kayaknya yang di breakout pada nggak ngerti tugasnya tuh Bu. File-nya ngerti ya? You still mute, I think, Bu Rini.
Okay, yes, I just visited many room. Some of them is silent. They don't know what should do. And some of them interactive. They share the print screen of my slide and discuss how to solve that.
Okay.
1 minute, Pak.
Some of them do not know where is the file that they have to work on.
Yeah. I forget to share the file before they go to the breakout room.
Okay.
Yeah, welcome back to the main room. Okay, I will check. Yeah, all of you has been in the main room, so I will continue. Yeah. Have you finished discussing the case? Is there a group that finished 2 cases?
Not yet, ma'am.
Not yet. Okay. Have you know your friends? At least one of your friends from other
Yes, yes.
university. Yeah.
Yes,
I
we
expect that,
continue.
yeah, you will know each other and then get interaction and get more contact after this, because it's only 15 minutes. I think you can do nothing in that room, but at least you have new friends and you can discuss many things after this session. Okay. I think that's all that I can share to you, and hopefully, all of the things that I share is beneficial for you. Keep contacts, and then make collaboration between students, or maybe you can also ask Pak Arif or me to make a supervision of your research, of your publication, and we wait your product and your paper in our conference in ISAST 2021. Okay, after this, I will give the chance to Pak Arif. Please, Pak Arif. Pak Arif will show you how to implement the concept in the Python. Okay, please, Pak Arif.
Wait. Okay, thank you very much for very nice opportunity to meet all of you guys in this very good and bad situation due to the COVID. Because I say good because now I can share everything with everyone in the world without even traveling to India or even to Europe or America. So it is good thing of COVID. The bad thing is, yeah, we all know that a lot of casualties and so on and so forth. So now I would like to talk about a little bit more about the image picture extraction. So, and I will bring you to an example how easy what concept that Burini already mentioned, already present. Probably you have a problem in try to calculate, for example, the moments, for example, or to calculate histograms. Actually, it's just difficult on the paper, but in terms of try to program, try to make it as a code, it's become very easy right now. Okay, so this is an example of an image, which is a digit 8. Yeah, it is on a grayscale color. So the number here from 1 to 255, it is 8 bits. Okay. So each of the dot or the pixel here has different value, and it's represent the color. Yeah. If you see deeper of the data, you will see a data like that. You can see it in Excel or display the matrix. Yeah. Okay. Okay. So it is more details. So 0 is totally black, while 255 is totally white. So the number between 0 and 255 going to be between black and white, which is gray. That's why it's called grayscale. Okay. So this is the detail. This is the screen representation. Yeah. and this is the matrix representation, the number representations, the numerical representation of the image. Okay, so what about color image? I think Purina already mentioned it, so I'll just leave it. And beside RGB and grayscale, there are a lot of different color space. For example, the binary color space, which is only have 0 and 1. 0 mean black, 1 mean white. So you can have black and white image. Another color space is HSV, which is hue, saturation, and value, and it is considered to be the the closest one. That's why when we have RGB and we want to take the feature of the color image, we use to SP. If you want to print something with a good quality, you can use CMYK or CE Labs and many more. Yeah, it is depend on what is the targets of presentation of the image, like in the screen, in NTSC, in PAL screen, they will need a different representation of the color. Okay, so, and then this is the low-level feature. Low-level feature is basically the value of the pixel itself. It is, however, it is meaningless for the people, meaningless for the human, but it is meaningful for the computer. Computer can display the image like my face or your face. It is because they save the picture value or the pixel value. Without the pixel value, computer cannot display the image. Therefore, the pixel value of the array of the pixel is designed not for human, but it is designed for the screen. Therefore, it's meaningless for the people, because if you see, for example, if you see this number only, you won't be able to understand what is it, or what we're gonna call the meaning or the semantics. We don't know the semantics by only see the number. Okay, so people perceive the image by their mind, and it is called the meaningful or semantically meaningful for people. Okay, so in order people to understand, people need higher level of the feature. Instead of dot or a pixel, people need more than a pixel. For example, what? For example, the line. Okay, if we have a line, for example, we don't know inside that, but it is a line. Okay, all of them are line. What is that? Anyone know what is that? What picture is that? Anyone know?
Face, human face.
This is the face, sir.
Human
it's
face.
The face, sir.
Okay.
Yes.
By extracting the line, then you will understand on average, people understand that it is the face of the people. Yeah. When you see this, yeah, even my drawing is not very good, then you will know what is that?
Car.
Car. Everyone know that is car. Yeah, even my child is 6 years old. No, what is that? Look, what is that?
Just a car.
Just a car. So that's wonderful. People know with higher level of the feature. So when we have a picture, then we need to extract higher level of the feature instead of dot or the pixel. We need to extract the shape, extract the line, extract the texture, extract the color distribution in order to make the people understand. Now, if every one of you understand, guys, because you are people, you are a wonderful made, yeah, you made by the God, yeah. Therefore, you are very clever, right? Everyone is very clever. But how about computer? Does computer know that it is space? Does computer know that it is space? No, ask the computer. Ask your computer. Everyone in front of the computer know, right? Okay, ask your computer. What is that? What is that? Because the computer can answer you. Can they answer you? Or even give a sign? No. Computer is really, really, really not clever. Yeah. Yeah. Really bad in perception. Therefore, we need to teach the computer to understand what is that. Okay.
No, actually, computers don't have.
Okay. So, can you guys recognize what is that?
Damaged car.
Yes.
Yes.
Yeah. Yes. Everyone recognize that. Okay. Because we have mind. Our mind consists of thousands of neurons. Yeah. Okay. So back to the feature. So when we have an image, then we'll divide it into two different kind of features. The first one is the global feature. What Kusrini already mentioned before. Yeah. We will extract some number, probably a single number, like the average of the color of the image is a single number. For example, let's say everyone can see the logo of Ravindar. Can everyone see that? Or okay. Can you see my face and my screen? Can you see my screen, my image, my video with my boy behind me?
Yes, sir.
Yeah.
Yes.
Yes, sir.
Can you tell me what is the average color of my video? Okay. Probably it's gonna be close to purple, right?
Yes, sir.
Yeah, because most of the image color purple. So okay, on average, it's gonna be purple. Purple, for example, the code of the purple, for example, 100, 100, 100. So this is an array consists of 3 R, G, and B. Yeah, 100, 100, and 100. Okay, so it can be a single number. It can be factors. Yeah, I will give you an example of that. Yeah, histograms. Yeah, histogram of gradients and so on and so forth. It is all of them are a single number, a single factor that is represent all of the image. On the other side, we have what we call it local feature. Local feature is what? Local feature is actually a number. Yeah, we will transform everything into a number because computer only know number. Yeah. So computer actually doesn't know anything instead of number. Okay. So if you take this presentation on this side, everyone can see this. This side. Okay. What you see that? Anyone see that? What's that?
What's on the side?
I put red here. Anyone see that? What's that?
Corner, sir.
Corner.
Corner.
Corner. You see this, you're gonna say that it is edge. Okay? So it is a local feature. It is not represent entire image, just a patch of the image. Okay, so you can use corner detections. You can use edge detections. Yeah, and so on and so forth. You can use, for example, all over this presentation, which one is the most attractive for you?
Like the tablet
Which one? Everyone can choose, please. Which one the most attractive for you? You attract from where?
Purple color, sir.
Or the purple color.
Purple color. Purple color.
What about this? Does it more or less interested for our eyes?
Sir. More light.
More light. Okay, so basically everyone, guys, in the world, yeah, like something different with the surrounding area. Okay, surrounding area. Yeah. If the surrounding area is white, then you are black, then you're gonna be the center of attention. Attention. Yeah. This is what we call it as salient area. All of this algorithm, guys, try to identify which one of the dot of the location of the area that is interesting. Okay, let's go on. So global feature extraction, global feature example. Okay, you see that this is me, yeah, when I was young. No, I'm still young. Okay. Okay. Do you see the differences between the left-hand side and the right-hand side?
the right-hand side is that one, and that's just upside down.
Anyone know?
Rotate picture, sir, in the right side.
Yes. The picture, is it different picture or the same picture?
Same picture.
The same picture. Yeah.
Same picture, sir.
So, do they the same picture? Yes. Yeah. You can answer is yes. Clearly, yes. Okay. Now, what we expect when you see this picture, is it different or is it the same?
You do like see the difference.
Okay.
Like see the difference for them.
Yeah. Okay. So what we want to do, if there are two different similar picture, what we want is that they are represented by the same feature. Okay. If you see the number here, probably this is gonna be and on this right hand side it's gonna be about 30. The second one gonna be 255, this is going to be 35. If we see that representation, that pixel representation, they are different. Why different? Because this picture here, this pixel here, gonna be on this side. So the matrix like okay, like upside down. Yeah. Okay. So if we rely on the pixel number, we will consider that those pictures are the same or different. Without seeing the picture, yeah,
different.
We will consider that they are different, but actually they are the same. Okay, so what we need, what feature we need? We need a feature that can produce the same number, the same feature for both picture. The same feature for both picture because those pictures are actually the same. Okay. Okay. So histograms is one of them. So does anyone in front of the computer? Yeah, if everyone in front of the computer, please come to wait. Please access this. I will give you a message in chat room. Okay. Okay. You can access this. This is an example, and we're gonna demonstrate how how easy we can extract the histogram. Only this function. This function consists of only 1, 2, 3, only 3 lines. Yeah, only 3 lines to produce the histograms of the image. And if you access, anyone see the chat room? See my message? Hello, could you please give me feedback, please?
Yes, sir. GitHub.
Yeah.
Data set.
Okay. Yeah. You can go there and then please click open in collapse.
On the way, sir.
Okay, click this one. Okay. Anyone got this? I'm sorry, I didn't have time to translate all of the texts into English. Sorry for that, but because programming language is, I think, the same for everyone all over the world, so don't bother with the text, but please see the.
Island has their own, text sheet.
Okay. Okay. So if you get to this, please click the opening collab. Okay. Anyone can follow me?
Yes, sir.
Collab. Yes, sir.
Open it.
Okay, good.
I am open it in Google Colab.
Okay, and then please save for your own. Please save a copy in Drive. So it's gonna be your own code, and you can execute in your own computer in your own Drive. You can use it for future. Yeah, please click this one. save a copy in Drive. If I'm too fast, please tell me to slowing down.
No, sir, the pace is good.
Save a copy in Drive, and if you have any picture that you want to use, please prepare your own picture and your own picture. Yeah. I also prepare the data sets. I share the link of the data set in the chat room. Please access the data set and save in your own Google Drive. It's called dataset1.zip. Okay, we'll play with that. We'll play with that. I already played with that before, so it was run before. You can run after this meeting, of course. And if you have any problem, just let me know, and probably I can help, or we can help each other, because some student of mine in AMIKOM already get this example. Okay. So basically, in this small programs, we are going to experiment with 3 global features, which are hue moment, heraldic feature, and also histograms. Okay. I use this picture, exactly the same picture with the one that I display in the presentations. And I already read this, and then I use another upside down picture.
That was the similar. That was the same one before the display.
Yeah, exactly the same one with different orientations. And then this part is a code to transform color image into gray image. I use the OpenCV library. So with the library, we do not need to calculate one by one like what we have you have been shown by Dr. Kusrini before. Yeah, it's like how to cheat, to get earlier. So, okay, as I mentioned before, that we need a feature that is be able to represent the similar image with exactly the similar representation of this similar feature. As you can see, histogram for the first is the histogram of image. Image is this image. Okay, this image. Yeah, this image, the image that is normal, not upside down. And this image, the upside down image, I call it as image 1. Okay, so this is image 1. And then I calculate the histograms, yeah, with the function that you already seen before. Yeah, I calculate the histogram for the image that is not upside down and the image that is upside down. And you see the magic is the histogram of this histogram basically consists of the number of a float number, a real number. Yeah, you can see the histogram is exactly the same. You can compare the first number exactly the same with the first number here. The first number here exactly the same with the first number here. So this is what we want from the feature. So the feature gonna be consistent if the image is exactly the same. But if the image is different, the feature needs to be different. Okay. The same thing happened with the view moments. Yeah, view moments. Okay, I'll back to the presentation. Okay, anyone have a problem to run this sample code? Or are you still downloading the data sets?
What the daddy? What's your computer like that? What is your tablet?
Hello?
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 Okay.
Why is it all day?
I would assume that you're still downloading the data sets, so I will back to the presentations. Okay, so extracting the histograms, despite the formula, is quite complicated, right? Here in the code, in the programs, it's totally easy. People said easy peasy squeezy. Yeah, you just need 3 lines. Okay. Okay. So this is the histogram of the normal picture. Yeah. And this is the histogram of the upside down picture. It's totally the same. That's what we want. Yeah, because same picture has the same representation of the same feature. So normal picture and upside down picture is actually totally the same. Yeah. Okay.
You just make the picture upside down.
So this is a grayscale. Yeah. Only one line to transform the color picture to the grayscale picture. Yeah. Thank you for the one who already made the OpenCV library. Yeah, they've worked hard for us. Okay. Okay. What is moments? Okay. So what is the moments is in very simplify. I would say that it is the average pixel intensities. And from the pixel intensities, we can generate another numbers. It is, you can see the theory in the the references on the references too. It's quite long to explain all of them, so I just leave it like that. Then you can read by your own. If you have a problem, again, you can ask either to me or to anyone in the internet. Don't worry, everyone knows about that. So don't really worry about that. But again, the good news is that to get the hue moments, you just need to two lines of code. 2 lines of code. This is the hue moment of the normal picture. Yeah. And then the one on the right down side is for the upside down picture. You can see it is totally the same. That's what we want of the feature. Yeah. Okay. Another one that we talk about here as an example of a global feature is heraldic feature. Heraldic feature is a texture, basically. It's a function of normal GLCM. What is GLCM? Because just type down in the Google, then you will have what is GLCM. And I will just show to you that you just need to transform to the gray level image, and then from the gray level image, we will see you just need another line. So you just need 2 lines of code to get the heraldic feature or texture. Textures represent how smooth or how smooth the image is. I will show you the differences between a smooth image and not smooth image with a textured image. So this is the heraldic, and you can see the upside down picture has the heraldic feature, exactly the same heraldic feature, but different picture. This is just for an example. This is a clear white picture. There is no texture, so you can see that the value, the factor is totally different. Okay, so this is what a texture is. Yeah. Okay, so those 3 are global features. There are a lot of different global features, but basically this number represent the whole picture of the entire picture or the entire image. Okay, so what is a good feature that we want? First, it is powerful to distinct between one to another image. So if the image is different, the feature has to be different. If the image is the same, so the feature has to be totally similar. This is what we want of a good feature.
Arif, your voice is not clear. Hello, Arif.
So your voice is not audible. We can't hear you, sir.
Sorry for disconnected. Okay, what I'm going to see with screen. Yeah. Okay, everyone hear my voice now? Okay, everyone here?
Yes.
Yes, sir.
Yes, sir, we can hear you.
Yes, sir.
Okay, thank you. Sorry for the network
sir.
problem. Yes. Okay, so this is what we want for the feature. Invariant to image modification. What is image modification possible? It can be, scaling. It can be rotation, and so on and so forth. A lot of possible modification of images. Okay. Now I'm going to move a bit to the local feature. This is an algorithm, a collection of algorithms try to extract the local feature. Sieve and serve is a very well-known algorithms. I think it was David Lowe here. But both of these algorithms are now patented. So we cannot free to use that. But don't worry, there are a number of different new feature extraction algorithm, local feature extraction algorithm like ORB, Brief, and Agas, which is still free for us to use. Okay, so this is an example. This is an original image, and when we execute a sieve, then sieve algorithm will, identify which pixel, which location, which part of the image that's invariance, that's that's salient, that's attract our attentions to make this point. If, for example, this this point can differentiate between one to another image. You can see on the background, there is no important key points that Sieve detected. Yeah. All of those algorithms, all of the serve, Sieve, and ORB try to identify the important points of the image that we're gonna call as a key point. Key points. So from, for example, we have 1,000 times 1,000 ORB, 1,000 times 1,000. So we have millions pixels. Out of million pixels, ORB just point out or just select number of dots, probably 100 or 1,000. So it's going to be very powerful for us to reduce the number of the data, for further processing. So this is brief. They try to identify the important location of the image. I have some example code, but it is not part of the one that I share with you guys. Actually, it was quite long for me, so I have to find in my computer. But sure, I will share in my GitHub if I found it in my computer. Sorry for that. Okay, and then I'll just leave it, and then I will talk about something very important for us now, which is kernel or filter. Yeah. Why we need to talk about this? Because it is the basics of all new algorithm now that you probably understand or hear before, which is CNN or a deep learning. Deep learning, one of deep learning algorithms in image in computer visions is CNN. Yeah, this is very basic. So I will talk about filter or kernel. So this is what you call it edge. Yeah, this is an edge. What edge is? Edge is basically a border. If this is an image, so for example, this is a frame of the image, and then you walk, yeah, move from the left hand side to the right. When you get this, what happened? If the white one is 255, and then when you get there, and then it's gonna be decline into, let's say, brown gonna be, let's assume that brown is 70. If you subtract the first and the second, how much the difference is? How much the difference is? Well, 255 minus 255. Anyone
Yes,
else?
how much will be the difference? Yes, students, please respond.
Zero, sir, zero.
It's going to be 0. Yeah. So if you walk from the left to the right, you will, and you subtract, yeah, each pixel to the next pixel on the right, you will get 0, 0, 0, 0. But when you get to this position, you subtract this 255 minus 70, yeah, you will get around, let's say it's around 100, 180. So when you get something like that, and you get a very high differences, that means you get an edge. You get an edge. So this is what edge detection is working. Yeah. Now, if we have to work manually like that, then it's going to be takes time. What people try to work on that, they use this. Okay. If I want to know whether what number is it? 85 in the middle is an edge or not, we just need to put this filter on the top of the image. Okay. And then let's multiply the input. This is the input image. And this is the filter. Filter image. When you get certain number, then you will see that it is an edge or not. This is a filter for vertical edge. This is the filter for horizontal edge. This is for horizontal. This is for vertical. Yeah. Okay. So if you have an image like like that, and we implement the filter, we will get this. We'll get this. And this line, yeah. If you implement the vertical filter. If you then implement the horizontal filter, you will get the horizontal line. Yeah, so it's gonna be easy. Yeah, as easy as that. Just implement the filter. This concept, guys, it's called the convolutional operation. The convolution operation, and this is gonna be the basic of CNN. The basic of the deep learning for image and video. Okay. This is a convolution. So in a convolution neural network, the basic concept, we have a filter, we have a convolution that I already mentioned before. We have padding, we have stride, and we have a convolution to volume data. So this is exactly the same. Yeah. If you put in the first round, first iteration, you put it here. Yeah. You'll get this. You will get this one. Yeah. You try to multiply everything, then you will get -5 here. And then you move 1 to the right. We call it stride equal to 1. If you move 1 every time, every iteration you move 1, you will get the other one. 3 times 3. Yeah. Put this filter on the top of the image and then multiply that, you will get -4, and so on and so forth. So do it from the top left to the right bottom here. You will get the result of the convolution. This is the basics operation of the CNN. Okay, and then yeah, this is the convolution I already mentioned before. And then if we convolve the input image like 6 times 6, the output gonna be 4 times 4 because we cannot get the replication of this. In order to do that, in order to save this, if we want, the output gonna be exactly the similar size with the input. We will need to modify the input by padding. Basically, the padding is putting 0, yeah, putting 0, yeah, 0 here on the right-hand side, on the down, on the left, and on the top. So it's look like our input is 8 times 8. The original signal, signal is 6 times 6, but it is virtually look like 8 times 8. Therefore, we can use the padding in order to keep the output with a similar size with the input. Stride is the distance of movement. 1 means you move 1 by 1. 2 it means you move 2 by 2. Okay, and then this is the convolutional for 3-channel image. Yeah, and this is the example result. With single filter, we can use multiple filter as well. And okay, here, yeah, really, how much time I still have?
Yeah, actually, it has been buka puasa, Pak. So the time is
Yeah,
it's okay, ma'am. It's okay.
Yeah.
Not a problem.
Yeah, I will just quite speedy to present thing. So
Yes, not a problem.
Yeah, quite quick. Yeah, we talk about the computer vision. What is the computer vision? Computer vision is basically an effort and in this interdisciplinary. Okay, it is an interdisciplinary scientific field that deals with how computer to be able to understand the meaning or the semantics of the digital image or video. So from the perspective of the engineer, it is to understand and automate the automation tasks that human visual system can do. So like we want computer mimic our skill, our eye skills, like make the computer have their own eyes. So this is how the computer vision, what the computer vision is. And then what is the image processing? This is the differences between those. So you can read by your own. I will leave this presentation with you. This is the low-level presentation, and what we want, computer know that it is A. Yeah, this is the computer vision one. So in order to make the computer has this ability, we need help of machine learning. Okay. So, and then what is the differences between machine learning or conventional machine learning and deep learning with CNN is that the conventional machine learning need feature extraction as a single task that you guys as an engineer need to decide it what feature and how to get a feature, like what we have been learned before. And in CNN, we will let the algorithm to do extraction by itself without we choose what is the method and what is the feature that we are going to put an attention on it. Okay. So this is the illustrations, and what, because we talk about the research in this title of this meeting. So what is the research in computer vision? For example, we want computer to know something, like we know, like pornographic image and video detection. We as a human can detect that it is porn. We want computer without our help can understand that it is porn and it is not porn. So the computer can filter by itself. For example, trash classifications or fake video detections, emotional expression detections, micro expression detection, face mask detection. All of them are computer visions. Yeah. And then what is the image and video processing research? Example, image segmentation, image restorations, video segmentations, image coding and compression, video coding and transmission and compression. Those are the disciplines of image and video processing. So image and video processing much prior, yeah, before the computer visions. Yeah, I myself, for example, we have some publications, yeah, in the computer vision and image processing. This is computer vision, computer vision, computer visions, computer vision, computer vision, all computer vision in this page. And this one are, yeah, this one is image and video processing, video processing, video processing, image processing, image processing. Yeah, those two are computer vision. Yeah. So I hope you can have an idea about the research. This is an example of video processing, image and video processing. I was working with that when I was in UK in my PhD research. My work is segmenting the video into objects. This is an example of a carbon video, and we try to divide it into small pieces, and then we want to make that as a graph. And then from the graph, we can cut the graph somewhere in order to define the object, because we want the people by the phone, the car, divided each other without understanding which one is the car. So it just used the low-level feature without learning. So this is not a machine learning problem. This segmentation problem. Okay. So when I cut here in the tree, then I will got the window and the rest. When I cut here, I will got this and the other object. So this is the basic idea of image segmentation. And this is another research in expression detections. This is still on press, and with my students, this is fact video detections. Yeah, this is computer vision as well. Okay, and this is the references. And thank you very much. Sorry for being very fast in the end of the presentation, because we've run out of time. We need three or four meeting to discuss about that clearly. And thank you very much. And yeah, I give the time for Miss Nikita, please.
Thank you so much, sir. Definitely our student would have been benefited by this expert talk. So let's move towards the conclusion of this event. So respected Professor M. Sianto, Dr. Kusrini, and Professor Arif Setianto, it's my privilege that I have been asked to conclude this session on behalf of Computer Science and Engineering Department, Chandigarh University. I must express my deep sense of appreciation for all our speakers for explaining our participant about the various research prospects in the field of image processing. I'm very thankful to the guests for this event for sparing their valuable time for our participants from both the universities, that is the Chandigarh University and the University of AMIKOM, Indonesia. I'm sure that all the participants of this event would have been benefited after attending this session. So in the end, I would like to thank our participants for being patient and curious listeners. Definitely this event would have not been a success without you people. So wishing you all a very good luck. Thank you.
Thank you very much.
Yes, over to Kusrini ma'am. So shall we conclude the session?
Yeah. Okay, Mbak Rona, are you still there?
Ya. Bu Gusrini mungkin ada penutup nih, Bu. Silakan,
Yeah,
Bu.
I think it's enough because the time has been limited. All of the students from AMIKOM are waiting for this time to buka puasa. What is buka puasa in English, Pak Arif?
Iftar.
Breakfasting.
Iftar. Breakfast.
Wah, ada suara piring, Bu.
Yes, please, Mbak Rona. Actually, I have shared in the chat room. We will give certificate for all of you when you have take the test, post test, and evaluation. Maybe you only need 15 minutes to do that test, but the form is open until 3 hours after this. So please take your time to do that post test.
Yes, I want to inform my students that the link for the test would be open for another 3 hours. Please complete the test within this given time limit, and the test would not take more than 15 minutes of yours. So please do the test and earn your certificate. Actually, you have spent time on this event, so please do earn the certificate. And moreover, our speakers have put in a lot of effort to make the things clear to you. So please do not waste their efforts. Right?
Yeah. Actually, I already shared the code, for example, and data sets, please let me know if there is problems. You can contact me in my email. And if you have research that connected to our expertise, please do so and let us know. It probably we can make any collaboration or working together on that area. Thank you.
Sure, sir.
Okay, I think enough, Mbak Rona.
Yeah. Baik Ibu, terima kasih. Thank you so much for all the speakers and also from the Chandigarh University student and all the student from AMIKOM. Don't forget to pass the test to get the certificate. And maybe that's all for today. Maybe it's not the last. We hope that this event will
Yes.
be annual or maybe next month or I don't know. Maybe we
Yes.
can continue this event.
Yes,
To
definitely. Definitely we'll keep following this trend.
Okay, so thank you so much, Miss Nitika Kapoor. We hope we see you again. Maybe
Yes.
in the few years, come to Indonesia and come to AMIKOM, yeah?
Yes, definitely. I'll visit your country. Definitely. Looking forward to do so.
Okay, we
Thank
hope
you so
so.
much.
Thank you. Okay, thank you so much. That's all for today. So untuk yang Indonesian people, silahkan selamat berbuka puasa. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you all. See you.
Thank you. Bye-bye. Thank you.
Bye.
Bye.
Bye.